Now let's consider the way to find the shortest possible stub. Let's begin with a series case. In the series case, let's say that we want to find the smallest possible L, but D can be anything. Here's our example for our previous load. Remember, there were two possible choices here and here for the value that we could have at A. So let's say this is ZA1 and this is ZA2. They're both viable possibilities. In the case of ZA1, we would read off this value, which would be minus Z of the stub. So Z of the stub would be up here. In the case of ZA2, we would read off minus Z of the stub 2, and Z of the stub 2 would be down here, right there. Now let's suppose that I'm going to use an open-circuited stub. Here is Z of an open circuit. Now we know that if we have right here ZS, let's take ZS1. Here is ZS1. We're going to rotate towards the load. This is wavelengths towards the load. We're going to rotate towards the load to get to the open-circuited stub. Good option. Now let's look at ZS2. ZS2 would only need to rotate this direction. So ZS2 or ZA2 would provide the shortest length of stub. So what you have to do is look at all the possibilities. There are only going to be 4 possibilities. There are 2 locations on the matching circle, and there are going to be 2 loads for the stub, an open circuit or a short circuit. There are no other choices here. So you look at all of those possibilities, you can just glance at them, and then from that determine which one is going to have the shortest possible length.